longitudinal image. See that one, this is a near wall and this is an far wall. But these are the assumptions which you have to keep in mind before you are going to start to do the work. Keeping the zone Z1, Z2, Z3. That is Z3 and Z2 is zone for an intima media. Z1 is your adventitia for this near wall. Whereas Z5 and Z6, Z4 represents your lumen zone. And Z5 and Z6 is that Z5 is an intima line. Z6 is that the portion between an intima and that is zone between an intima and media. Z7 is your adventitia. This is for our naked eye analysis. I coined it as this zones. Okay. So because we have to keep some reference for that one. Our ultimate idea is to measure that lumen diameter LD and IMT. That is that pixel values in between the zones Z5 to Z6 and Z6 to Z7 upper line. That line has been represented as I5 and I7. And this represents, see here, this is a manual line which I was traced that one to indicate my system to locate where these zones are in that one. Clear? So while you are drawing that one just like that, you couldn't trace that one. After determining that n number of image profiles for this pixel to this pixel, it has to be drawn. Okay. And this is a view of B mode common carotid artery sample frame showing this one. And this represents a median filtered. After filtering, it's very clear that one. This is a bundle of information, the isolating and lumen, and this is, see that one there is some variations after filtering. Is could you able to identify? So it's clear that one this is a place where that lumen intima and this is a place media adventitia is there. Okay. So this might be of the place where we have to measure IMT. It is just like that, you can't keep some scale to measure here. Clear? And this is a cost function for a single values where we have done that C into C gradient and C discontinuity. This is for a single pixel for a cost function, and its three-dimensional graph has been plotted for this deferred cross function. You can able to see the difference of that values in intensity. Okay, that variations has been happened in between that I5 and I7. What's that I5 and I7? This one. I5 represents lumen intima interface. I7 represents intima media interface. So it's clearly shown in that graph, because if you want to show something, you have to represent everything as in a graphical way to show that reviewers or an examiners to visualize the content in a better way instead of giving a statistical data manner. Okay, so this is a segmented portion. Okay, this is a lumen, this is an intima, this is a media for a dynamic programming procedure for your transverse section. Okay, this is for a longitudinal section. Could you all able to understand? So while seeing itself in your transverse section, in other tissues and adventitia is not that much clear, whereas in a longitudinal frame, it will be of very clear. Okay, so this might be of your intima media thickness. This segmentation is done with the help of improved dynamic programming procedure, and this is a graphical interpretation. Okay, so for 1 mm it is approximated with this 8.52 pixels. These are the values which actually obtained in that programming. Okay, so it represents this distance. Okay, actually our ultimate idea is to measure the distance between intima and media. Actually this is an intima and this is an media. Difference between things is represented here. Clear? So this represents measured value of an IMT of an far wall segmented B mode images for transverse view. Okay, so for this one. Okay, and this is for an measured IMT of far wall segmented B mode images for a longitudinal value. Okay, Yes, and this table discuss about this has been done for this much amount of subjects within different sexes, male, female, likewise in that one. These are that amount number of subjects which are involved in this one for different age groups. See that one for an age group of 21 to 30, 19 different subjects of female patient has been taken. The intima media maximum value is this one. Minimal value is this one, mean is this one. This is by this method, dynamic programming method. What do you mean by here as manual method is the values which was measured by that radiologist. They see the difference. This was that measurement which was done by this dynamic programming method by a machine, what we are given that coding with the help of this knowledge, and this was that manual method which was measured by the radiologist. By this is by one radiologist and this is by another sonologist for the same patient. Okay, so that inter observer error, what's the difference between this person and this person observer, and inter method in between this DP and manual method is this one. Okay, you see that difference. So this is the coefficient of variation as compared with this manual method and DP method. So whenever you are doing something, you have to compare with the basic standard methods with this manual method. So you have to done these measurements only with that radiologist, where you are going to get a data or where you already got a data for your further work in that one. And this is done only for an normal healthy subjects which you are consider in this one. Okay, and this is an graph. It's showing intima media thickness of common carotid artery for normal subjects. See this one. This is an age of a subject in years, 10 years old, 20, 30, 40, 50, likewise up to 90. This shows the thickness of the CCA in mm. See that one. A normal patient for at an age of 10, okay, it might, what's that information up to? Nearby 3.5 something. Okay, then 20 is nearby 4. And this is nearby 5, 6, likewise. It keep extends. Okay. And see that one. This is an age of abnormal subjects with years. Okay. There are two different patient details. One is the patient with plague details and other the patient with hypertension details. You see that one. That age of normal subjects at an age of 50 might have expecting that information at this point. Okay. What happens here? At the age of 50, you see the thickness. For hypertension patient, it's more than 1.2. For an atherosclerosis patient, more than 2.4. So it shows that evaluated data, it's supported and tells that when the patient who is having thickness more than 1 mm might be of an abnormal patient is. And see that one. This is an sample subject of MIMOR CC image with hypertension. Where is this? These are done with the help of without any disease. Okay. But the patient with hypertension, high pressure value is considered for this one. This is segmented. And see that one. Could you able to view this one? Some additional diseases are located here. Yes, in this lumen. That segmented information as in this. You see that bound of thickness. Okay, this is an atherosclerosis. But for this dynamic, it can't support that much. Okay, well, viewing itself, it won't show that much thickness difference. But in active contour, you can get a clear information. And likewise, thickness measurement has been done for this hypertension and atherosclerosis information. And this is an intima media thickness of the common carotid for abnormal subjects like hypertension and atherosclerosis. See that one. By this method, the measurement is there. By the radiologist, the measurement is there. The difference is this much. The correlation coefficient is this much. Okay. This conventional method, it shows that radiologist detail also. Okay. It is not that much deviated from this. And this is in results of active contour segmentation method. This information which you took from another machine, that information is not. This is in common carotid artery hypertension subject. That same thing, you have to fix an ROI profile for this one. Here you are going to determine that, see that one, upper vertex, lower vertex. You are going to consider this band of information out of an overall image. Okay, the C picture shows that initialized RO image of hypertension subject. This is SRAD. What's that SRAD? Speckle reduced anisotropic diffused image with contour. Okay, so it's clear, that one. See that one. How far this contour, it's clear in this one. After filtering, contour is very clear. See that one. External energy of RO in hypertension subject. This is an external energy indicator. B represents the total energy, external come internal. Okay, this is in segmented. That energy is pour over in that one. Clear. This is in total energy. Could you able to understand? So this is a portion which you are taken for active contour segmentation while keeping this ROI as the same procedure, keeping that vertex, and you are performing intimal layer contour extraction and medial layer contour extraction. After this SARD reduction, it performs, okay, could you able to understand, perfect segmentation has been done in this active contour or snake as compared with this segmented value. Could you able to understand? Okay, but this dynamic programming segment, see here. Here is also the appearance is lumen. Here is also that small portion is appearance is in lumen. It can't segment in a perfect way. Whereas here, Paka segmentation is done. Still there is a small variations in that one. See here. Could you able to identify this one? Some atherosclerosis portion is there. Okay, so this is a cursor which is located in that automated ultrasound machine, but in our algorithm again you have to keep an vertex of it, and SRAD active contour is performing in this one. See that one, how wonderful this technique, perfectly segmented and matching that one. Okay, but in atherosclerosis and all, you couldn't measure that intima media thickness. Where there is intima, where there is adventitia, it is tough. Clear? While seeing the picture itself, it's very clear. See here, there is a possibility of intima media is here, but within a lumen there is unwanted tissues are there. Okay, and this is an actual way of measurement in hospitals. They keep this information. Could you able to understand? Keeping the cursor and they measured. See here, it was shown in that one. Okay, this is a common carotid artery of diabetes subject. And again the same procedure, vertex has been identified, speckle reduced, external energy, total energy. External energy is passed over to this, and internal. You see that now small minute portion gets segmented in this one. Okay, and IMTC same procedure is done, and here you can get that one. For this dynamic programming method, for an age group of 21 to 30, 15 male sample components have been taken. This is an IMT mean, and this is an IMT mean for AC method. Actually this value is lower as compared to this one. So as by means of this one and compared to these two methods, accurate information you might get from this AC, that is active contour, as compared to dynamic programming method. Okay. And likewise for abnormal subjects like hypertension and atherosclerosis, see that one. Now for that intima media mean and this one, inter-method error and the correlation coefficient is there. And this is a sample of information which is done for transfer section of B mode normal subject. Okay, filtered image of normal subject. Just contouring is superimposed in that one. This is actually my manual cutting. It's not a machine, it's cut. Okay, but you can't perform these kind of option because generalization is tough. Okay, just I crop this information and segmented. I check that one, that external energy also performed well for this one. Okay, but you can't do the things as in this way. And actually it is not an atherosclerosis. I poured some content over it. Okay, check with that one to check how far the segmentation performing is in a good way or not way. Okay, it performed well. Okay, you can see that. But if you are given that algorithm in this way, then doctors and others get confused. See that one, the layer of intima media is here, but itself gives 3 lines in that one. That's our image processing algorithm. Okay, it made us fool. It is not a real one. Clear? This one. Could you able to understand? Segmented image of normal subject, segmented image of abnormal subject. So they might interpret these things as